In this next video, I'd like to demonstrate the relationship between a graph and its inverse. So we're going to be graphing functions and their inverses, and there's this relationship that's going to be between the two images. So the first image that I graphed here was of a triangle that had ordered pairs of -2, 1, 5, 2, and -1, 4. If we're going to graph the inverse relation or the inverse function of these ordered pairs, we simply turn the ordered pairs around and we plot those points. So instead of the ordered pair -2, 1, we plot the ordered pair 1, -2. This is the inverse of that ordered pair. Then I'm going to graph, instead of 5, 2, the inverse of 5, 2 is the ordered pair 2, 5. And the inverse of ordered pair for C, the -1, 4, is a 4, -1. Now I'm going to connect those vertices because it should be making a triangle, and here's the triangle, or the image of the triangle that we get for the inverse of the original blue triangle. Now the relationship I want to demonstrate here is every time you graph an original function and its inverse is that there is some symmetry that is displayed in your graph. The symmetry that is displayed is going to be this purple line that I'm going to show here. That purple line has an equation of y equals x. So I'm just going to put that on it. So this line y equals x will be the significant part of this story I'm trying to tell at this point. That line y equals x is a line of symmetry, so that if we were to reflect the ordered pair -2, 1 over the line, the purple line, we would get the ordered pair 1, -2. If we were to reflect the -1, 4 across the purple line, it should become 4, -1. And the same story is true for if I reflect 5, 2, it becomes 2, 5. So as we see with any graph that we make of a function and its inverse, these points should be a mirror image or reflection across the line y equals x. And that is part of what is always true about inverse functions. So that's a physical demonstration or visual demonstration of what inverse functions look like if we graph them both on the same axes, and pointing out the significance of them being a reflection across or a mirror image across the line y equals x.